Let's talk about a cybersecurity storm that's brewing, way out there on the horizon. It's a threat that's poised to break the very foundation of our digital world. And it's really not a matter of if it's going to happen, but when. So today, we are going to break down this quantum threat and talk about the absolutely critical steps you need to be taking to protect your most valuable information.
So let's just cut right to the chase with a really important question. Think about your organization's most sensitive data. The financial records, the secret intellectual property, all the stuff you're encrypting and storing right now. Could that data already be at risk? Just sitting there, waiting for some future key to unlock it all. The answer, and it's a bit of a scary one, is yes. It absolutely could be.
All right, let's dive into what this is all about. To really get a handle on the risk, we first have to meet the threat itself. And what we're talking about here is a totally new kind of computing power, one that fundamentally changes the entire security game as we know it.
And here is the villain of our story. It's called a CRQC, or a cryptographically relevant quantum computer. Now, this isn't just a slightly faster version of your laptop. No way. This is a machine so powerful, it can crack the really complex math problems that are the bedrock of our current encryption standards. We're talking about things like TLS, the little lock that secures websites, and algorithms like RSA that protect your data. A CRQC can basically shatter them into a million pieces.
So you might be sitting there thinking, okay, but we don't have a CRCQ just yet, so what's the big rush? And that right there brings us to the most immediate and, frankly, the most sneaky part of this whole threat. It's a strategy that adversaries can use, and you've got to believe they probably are using right now, today.
The attack itself is actually pretty simple, which is what makes it so scary. Step 1. An attacker gets in and just vacuums up all your encrypted data. To them, it's just a massive, unreadable jumble of code. Step 2. They just store it. They don't have to break the encryption now, they just have to be patient and wait. And then, step 3, years from now, whenever a CRQC becomes a reality, they just feed all that old data into it and unlock everything. The theft happens today, but the real damage, that comes later.
So this is the main takeaway. Waiting is just not an option. Look, overhauling an entire organization's security infrastructure is a huge job that takes years, not months. And while we don't have an exact date for when a CRQC will show up, everyone agrees it's coming. That means your data with a long shelf life is already in the danger zone, and the entire industry is already starting to move to a new standard. You don't want to be left behind.
Okay, so if our current way of doing things is basically doomed, what's the fix? Well, the good news is that some of the smartest people on the planet have been working on this for a long time. And the answer isn't just more of the same, it's a whole new kind of math.
And this is it. It's called post-quantum cryptography, or PQC. Now, let's be super clear on something. This is not quantum cryptography. It's actually the opposite. These are brand new classical algorithms that are built on math problems so ridiculously hard that even a super powerful quantum computer can't solve them. This is the software-based solution that's going to protect our data in the quantum age.
Now, you may have also heard about something else called quantum key distribution, or QKD. It's really important to understand why PQC is the one experts are backing. The Australian Signals Directorate, for instance, gives a firm yes to PQC. Why? Because it's software-based, and you can integrate it into the systems you already have. QKD, on the other hand, needs specialized, very expensive hardware, and it has some serious practical limitations that make it tough to use on a wide scale.
Okay, so we've established that PQC is the answer. But what does the rollout actually look like? Well, the ASD has put together a really clear and, to be honest, a pretty urgent timeline that every single organization needs to pay close attention to.
Your first big deadline is the end of 2026. By that point, you need to have a detailed, refined transition plan in place for your organization. And we're not just talking about a vague idea. We mean a documented strategy that accounts for all your specific systems, your risks, and the value of your data.
Then, just 2 years later, by the end of 2028, it's time to put that plan into action. You should begin the actual transition, and you're going to start with your crown jewels, the systems that are absolutely essential to your operations or that handle your most sensitive long-term data. And here's the final finish line. By the end of 2030, the transition has to be complete. That means you are fully moved away from those vulnerable old algorithms like RSA and ECDSA, and you are 100% operational on the new approved post-quantum algorithms. This timeline from the ASD really puts it all into a single picture. You can see those 3 big milestones, plan, commence, and complete, all mapped against the rising probability of a CRQ'd appearing.
But look at that shaded box, the period of vulnerability. It shows that for data you need to protect for 10 years, that risk window actually started before today. That, right there, is why the clock is ticking so loud.
So this all feels pretty massive, right? How do you even begin to tackle a project this big? Well, thankfully, there's a really clear framework you can follow to guide you through the whole process. So let's check that out and see how this turns into a real concrete plan.
This is the Lattice framework. It's a great way to break this whole huge project down into 5 manageable phases. You've got locate, assess, triage, and implement. And then running along the bottom, you have the continuous part of the process, communicate and educate. Let's just take a quick look at each one. First up, you have to locate. It's simple. You can't protect what you don't know you have. This whole phase is about discovery. You need to create a complete inventory of every single place your organization uses the old-school cryptography. This is where creating what's called a cryptographic bill of materials, or a CBOM, becomes absolutely essential. Next, you assess and triage. Okay, so once you know what you have to figure out what matters most. You assess the value of the data each system is protecting and what the business impact would be if it got compromised. Then, you use that info to triage, just like in an emergency room, to create a prioritized list of which systems need to be moved over first.
The fourth phase is implement. This is where the rubber really meets the road, where you apply the new PQC algorithms. Now, this could mean anything from patching software to swapping out code libraries or even buying new hardware. The most important advice here is do not rush ahead of the standards. You have to stick to standardized, verified, and reputable software from your vendors.
And finally, we have communicate and educate. And this is not a one-and-done step, it's a process that never really ends. You've got to be talking to your vendors, training your tech teams, and constantly monitoring your transition to make sure you're staying safe from both the old threats and the new ones.
And look, if there's any doubt left in your mind about how serious this is, this quote from the Australian Signals Directorate really says it all. This isn't just a friendly suggestion or a nice-to-have. The official expectation is that all organizations will make this transition. It's a fundamental shift that's required to stay secure in the future, period.
So that really brings us to the end here. The evidence is clear, the timeline is set, and the framework is there to guide you. The only question left is the one you have to ask yourself, and you have to ask your organization. The quantum clock is ticking. Are you ready?